if you're taking a physics class or otherwise reading up on physics, and there's a very basic part of physics that's like, I'm sorry, I spaced out for a second. Okay, so you got your distance graph, distance time, velocity time, acceleration time graphs. They're really important and basic to the whole basic physics thing. And if you don't quite understand how they work together, then it's really hard to, do all the problems with it and other such things. So, here's the simple way I figured out of realizing how they work together. And everyone in my physics class could easily understand when I explained it this way. So we'll go with this as the easiest way to understand it. So you've got your distance, velocity, and acceleration. Woo. I think that's how you spell acceleration. This is a physics video, not English video. Right, okay. Yeah. There you go. Now you make a graph for each of them. So the first example we'll do, just a graph. First example we'll do is say you just have a constant velocity of 1 meter a second. Right? So distance, you got your meters, your seconds. Velocity, you got your meter per second, your seconds. For acceleration, you got your meter per seconds, or meter per second squared, and seconds. Yeah? Yeah. Fun things. Very nice. I'm very proud of myself. I can write things in a dry erase board. So if you have this, you're moving 1 meter for every second, then you have a linear slope for your distance, right? So you have 1x. Yeah? Yeah. Now if your slope is 1 meter in second, then that means your slope is 1 meter per second, which would give that 1 meter per second. So you've got that as your value. The slope of this is the value of this, right? And now the slope of this is a flat line. So what's the slope of a flat line? I don't know if you can see that or not, but here's the slope of a flat line. Fat line. Flat line is 0. Right? Right. Now if your slope is 0, then your value is 0. So if your slope here, on your slope here, yeah, you basically got 1 here because that's your value, right? And you got 0 here because that's your value. Right. So it makes sense. Now here's the cool part about it, is that it works the other way too. What's the area between 0 and 0? It's 0. So the area of that is the slope of that, because the area between 0 and 0 is 0. Your slope of that is 0. So the area between 1 and 0 is 1. Your slope is 1. Very cool. But it works every time. It works for everything. Because say, we'll start with acceleration this time, you're accelerating at a constant rate. You're accelerating at a constant rate of 1 meter per second, like so, right? Then that would make that 1, makes into a quadratic. Well, it's always a quadratic formula, it's just that it wasn't filled out before. But if you're accelerating, all it does is it fills out. So here's your constant. And so that would make this 1x. So area between this and 0 is 1. That's 1. 1x. Now what's the area between this? The area between this is 1x, right? So you get 1x x. Let me rewrite that. Okay. 1x x. Yeah? Which is x squared. And x squared is a parabola. So, moving up and down these graphs in this order, doesn't really work in another order, because that's how it works. Your distance, the slope of that, and the slope of that at any given point, you do the whole tangent line, and the slope of the tangent line at any point would give you the corresponding value at velocity. Fun fact of the day. I guess it's all fun fact of the day, but you get it. Yeah. Anyways, this, that, and that. Slope of that's 1, the area that's 1. So there you go. Screenshot that, remember that. That is how you remember the distance, velocity, and acceleration graphs and their wonderful lives together. Yes. Let me find my mouse now. Shoot.